Welcome back, Math 7. Today we are starting our last unit, or chapter if you will. The last chapter, which is known as Working with Data. And that is available on your textbook or PDF file of the textbook inside of my Google Classroom. It is available at page 428. Now, before we getting into, I need to make sure that what does that mean? Working with data. What is the meaning of this? Basically, working with the data means statistics. It is one of the math field that you will find in high school math as more detail. And when it comes to post-secondary like university or college, you actually have statistics as a major degree. Statistics is not only a study of a set of numbers like probability, but it also basically summarize and make the hundreds, thousands, million set of data into a simple calculated average or median, those kind of value. So basically statistics is a field of study. And in Math 7, this is one of the beginning. As you may notice, in textbook it goes chapter 12.1, 12.2, and then it goes on and on. But one thing that I want to point it out is I'm going to start with chapter 12.2. The title of that is Mean, and that page is 428. The reason that I'm starting with this mean is because that's what you will probably use the most, I like to say. And it's easy to approach with that first. Mean is basically, as you may notice, it's not literal, oh, you are mean, those kind of situation. Mean is not as used as an adjective in here. It is more a noun. And when you say the word mean, it doesn't look like it's unfamiliar term. You may know this more. It's exact same as what you hear in normal life, average. Like people say, what is your average? What is the average height in your class? Something like that. So average is what we generally use in daily life, but in fact this average, if it's statistic term, it is mean. So what is an average? Why people calculate average? People calculate average because it is one of methods that explain a central tendency of data. It's one of the methods to describe and explain a central tendency of a data. That means, for example, you may have multiple different data. How can I know the middle ground of the set of data? And mean, which I'm gonna show it as average, those are one of the methods that you can use in the world of statistics. The way that you calculate average is this. Sorry about the noise. My puppy is actually playing with the toy. So average can be found by first adding all of the values in the data and then divide the sum of those value with the number of value in the set. That's how you do. So when you look at these, it seems like it's a complex wording, and it is true, but this is the way that you can do. Imagine, for example, you pick a card 1 to 10. And you're picking once, twice, and thrice. And you record the value. The first one, you pick 6. Second one, you pick, let's say, 8. Third one, let's just say you pick 4. How can I find the central tendency of the data? Here's what you do. First of all, you add everything. 6 was my first value, second value was 8, third value is 4. Then you will divide it with the number of data. So first, second, third, that means we have total 3, so divided by 3, something like that. Then you will know that 6 plus 8, that's 14. 14 plus 4, that is 18. So 18 over 3 is what you will have, which is equivalent as 18 divided by 3, which is equal to 6. So as you may notice, this 6 is the value of mean or average of this certain set of the value. Right now you see 6 and 8 and 4, you get a clean value, but sometimes you will not gonna have a clean value. For example, you're doing the exact same set, 10 cards, and you pick 3. And let's say you have the first value, instead of 6, you got 5. Second, let's say we're using the same number, you got 8. Third, you got 4. And how can I find the mean value? Same thing. 5 plus 8 plus 4 divided by 3, because I have 3 sets of data. 8 plus 4 is 12. 12 plus 3, that's 17. Now here's a problem. The previous example, 18 over 3, 18 divided by 3, whatever you want to call, they actually can be calculated easily even without the calculator. But now we may need a calculator. 17 is not a composite number. It just can be divisible by 1 in itself. So 17 divided by 3 will give you some kind of nested decimal. And when I punch those numbers in calculator, it's 5.666 dot dot dot. So you need to round it up. Round it up to 2 decimal places, like 5.67. That is an average value. As you may notice, this mean values that we got from first example and second example, one thing that you need to understand is it may not be the value from your set. Like the first example, my average value turned out to be identical as one of the set of number. But when you look at the other set, my average is not a whole number, 5 or 8 or 4. It is somewhere in between of those number line. So if I put it, like I said, as a number line, let's say here's a 0, 1, 2, 3, 4, 5, 6, 7, 8, gotta make more. One of the value was 5, one of the value was 8, one of the value was 4. It seems like mathematical calculation, if you add it up and divide it, the central middle point is somewhere over here. 5.67. And if you use a ruler, that rather makes sense, because 4 to 8 and then somewhere in the middle, something like that, then that's quite close to 6. Even though 4 and 8, that's a 2 set of value, we need to consider 4, 5, and 8, and then the middle point of those 3 set. That's basically how you can calculate the average value. And the word average in the world of math is known as min. Let's do a quick activity. It's a non-spot question. Now, what I'm going to do is, and this is a material that you need, It's your choice if you want to use this material or just follow through what I'm doing. I'm gonna use a deck of card. And I am going to take 5 random cards. And as you may notice, there is, yes, other than the suit, like clover, but clover and spade both are black. Heart and diamond, they're both red. So I'm going to create 2 sets of data. One set of data is anything that red, another set of data, another that is black. And I'm going to calculate the average of red and black and compare. And of course, if I happen to take out Joker or Jack or something like that, I am not gonna include those. So I have this bicycle. I think that's the brand of it. My first data, 8. Next one, Jack. Let's just skip. Let's just do number. Next one, clover, but 3. Green, let's just omit that. 2. It seems like I didn't mix it well enough. Seems like it's black all the time. 8, that's 1. One last set I need. 4, that's red. 3, that's red. 9, that's red. J, omit that. 7, that's red. 4, that's red. Rest set is done because I have 5 set. 2, that's red, so let's omit. Black 10. There you go. If you want to roll the dice, that's okay too. But I like this deck of cards because it gives you quite a variety of set of number. Now, let's look at each. Red, I have 5 data, 5 data for the black too. Now let's compare which one's average is higher. One of the set is 43974. Another one is 832110. Of course, the biggest number is included a black situation, but does that mean the average for the black cards is larger just because we have a bigger set? We don't know, because if you look at it, rather 1, 2, 3, those are smallest number, and when you look at red, 1 and 2 are not even existing. So let's do the calculation. Mean value for red, I'm just putting a little subscript. Let's add everything. 4 plus 3 plus 9 plus 7 plus 4 divided by how many set? 5. So average calculation may differ every time when you encounter different problem. But let's do some calculation. I'm gonna try to use mental math. 4 and 4, that's 8. 9 and 7, 16. And 3. 8 and 3, that's 11. Which means 11 plus 16, that's 27. Divided by 5. And if you want to use calculator, this is a good time. If you want to do mental math, that's okay too. 5 times 5, that's 24. So 5 point. And 20, that's 4. So 5.4 is my mean. As you may notice, I don't need to round it because it is a terminating decimal. That means it's not repeating infinitely. That's my average value for red. If I do average value for black, then we can add it. Black 8 plus 3 plus 2 plus 1 plus 10 divided by 5. Again, I'm going to use my mental math. 8 plus 2, that's 10. 3 plus 1, that's 4. And 10 left over divided by 5. that is equal to 24 over 5. If you want to use calculator, feel free. If you want to use mental math, that's okay too. It's not as hard. 24, there's 4 times 5, that's 20, and 40, that's 8. So 4.8. So now we can basically compare my average value of red versus average value for black. Which one is higher? Well, it turned out red is a bit higher, because the thing is, and this is where you can estimate a little bit. I know the biggest value is located at black, the black sets. However, as you may notice, you also have a least amount, which is 1 and 2. So these two basically bring the average value downward. On the other hand, when I look at red, it is more consistent. Like 4 and 4 were consistent. 9 and 7 are located pretty much high. If there's anything that catch the leg of it, it's actually 3. But 3 compared to 1 and 2 is still higher. So you may notice that red, maybe its average is higher at the beginning. And what do you know? It turned out to be true. Average value of red is higher than average value of black. And that's how you do. Let's do a textbook example and then finish today's lesson. For 20. I cannot find 430. There you go. Sorry it took some time. I was opening the PDF file of it. And I'm gonna do example number 2. Alright, a scientist recorded the daily distance traveled by a spawning salmon for 5 days in a row. And we have a set of data and we have several questions. A, what is the mean distance traveled by the salmon each day? And how far would you expect a salmon travel in next 10 days? And C, Chinook salmon may travel 8,000. How can we get there? Those kind of things. So let's do what we learned for the first. Mean value. Right now, from the textbook, I have Monday to Friday data. Always start with the fraction when you do the average calculation. Monday we have 44, Tuesday 52, Wednesday 51, Thursday 46, and Friday 57. And we have 1, 2, 3, 4, 5 data. So that's what it is. Of course, you can write it like this, but if you want to put it in your calculator, good idea to have a bracket. And we are going to use a calculator. Hope you can see. 44, 52, 51, 46, 57. Oops. Divided by 5. That gave me 50 kilometer. So that means our answer for A, the average distance or the mean distance, I'm going to use it as a sentence. The mean distance traveled by salmon each day is 50 kilometer. Of course, it's an average. That doesn't necessarily mean every day you travel that distance, as you may know, right? Now, let's do B. B question is asking, how can we predict the next 10 days of distance? So you can think it in that way. one day, as an average, salmon travel about 50 kilometer. So if it's 10 days, that's what the question is asking, right? It is simple ratio. It's like 1 to 50, then what if it's 10? So as you may notice, to get 1 to 10, that's multiplied by 10, right? So you do the same thing. So 50 multiplied by 10 will be about 500 kilometer travel as an average. That's what you can do for answering B. C is quite tough if you think about it. It says the total distance from this area to another area for the journey take about 8,000 kilometer. That's my total distance. Well, the salmon's total distance. And then the question asks you how many days will it take? Well, it's like going backward. So what you can do is, again, what we calculate from our A question. One day was about 50 kilometer. We're trying to get from 8,000 all the way to there, right? Or 50 all the way to there. We try to guess some of the number. The one easiest way you can do is 8,000. I want you to divide it by 50 because 8,000 kilometers is a total distance and 50 kilometer is per one day. So if I divide it, then we may find out how much days it take. And if I do 8,000 divided by 50, you will get 160. And that's basically how many days the salmon can take. That's a big journey. Assuming that you go 50 kilometer every day. That is quite challenging. Alright, as a practice, I'm gonna give you some homework question over here. It's from textbook page. What is this page? 431. Gonna distribute its question in a different way. Four and 7. Nine and 10. The last one, oops. Let's see, 14. So you have these 5 questions. That's today's lesson, folks.